Hello, so this is going to be going over lab 2. This lab was actually pulled up. What was this lab? So this lab was acceleration of gravity. So what did we use for this lab? We used for this, what are you going to need for this lab? How we just said the apparatus, So you're going to need a stand, a string, and a weight. So for that here, we have our stand, our string that we're going to tie, and the weight. So for this is actually, this lab is actually, we're going to actually determine, so what we're going to do is place the stand on the floor, measure 5 lengths of the string, tie to the center of the vertical support and the center of the mass. What does that mean? Okay, so center of the port. So here's the center of the port right here and the mass. So this is our mass right here. You can't tie it to the bottom. You can't tie it to the top. It has to be to the center for that. After that is done, we are going to record how long in seconds it takes to get 30 oscillations. So what is 30 oscillations? So that means basically when it goes from one side back to where it starts. So if you see this little cross here, if you go this way, back, that's 1. This way, 2. This way, 3. So and that's kind of funny because the first time we did this, we actually measured, so this measured how long it's put the mass and record how long in second it takes to get 30 oscillations. We first messed up and we actually measured how many got in 30 seconds. So how long does it take to get 30 oscillations? What was the proper thing supposed to do? So you're going to do it and take it in 100 centimeters. So you're going to measure from the pole. So we're going to measure from the bottom here down. That's 100 centimeters. Measure that, and then record how long does it take to get 30 oscillations. Do the same thing for 75, 60, 50, and 40 centimeters. Record the time and use the formula for the results. The answer should be between 9.35 and 10. So for us, let's move over here a little bit. So this is actually ours. So time in seconds. So for the first one, I know it says 100 centimeters, but ours was a little off when measured. Still works. I mean, it still used the calculation. So for ours, it took, for us to get 30 oscillations, it was 69. So we measured, how many people was it? Sorry, let me look at this again. So this for each person. So 60, 59, 58, 61. So that was our average time, or everyone's time to get 100. For set length of 72 was 51. And this is actually recorded for each length here up the top. This is your length. This is how long it took for each person. Then we need to find the sum of this total. Then we divide it by 12, which because that was the total number. Let's verify this. Let me make sure this is 12. Yes, 12. So you divide it by 12, which gave us our average of 59.85. And then we wanted to know how long it would take to get 1 oscillation. So divided by 30 seconds, and 1.9 for 1.95 was that. Then we plugged that into our formula, which is down here. So let's see here. So our total sum time was 667. We divide by 12, which I got 55.58. Divide that by 30 to get a single isolation of 1.85. Then you have to put that, so 1.8 was what it was for our single. So then you put it in our formula. What is our formula? Our formula is our 4 pi square divided by time. 4 pi squared divided by 4. Oh, I'm sorry. I'm sorry. Let me tell you this right. So the formula is gravity equals 4 pi squared divided by length over gravity. Yeah. So, and I made this easier in the Excel. So where you can see it is 4 times 3.14 times 3.14 times 0.97. And then you have divided by 1.85 divided by 1.5 because it was squared, which gave us, our answer was 11.14. And we actually were a little bit high than what our standard should be. But I mean, that's what we had. So even after repeating the test, that's what we totally got for this. And that was for the lab we did on 8/27. Thank you.